1969 BC 45, we have the complete interval of convergence for the series sum from 1 to infinity of x plus 1 to the kth over k squared is going to be what? We'll use our shortcut method first. We can tell that x equals -1 should be the center here, and since it has to be symmetric about that center, it cannot be 0 to 2, cannot be 0 to 2, and so we're down to 3 choices, which is a good thing. And the only question is what happens at the endpoints. So one of our endpoints is -2. X equals -2. Let's see what we have. -2 plus 1 is -1 to the kth power over k squared, and that is an alternating series. It decreases in value, decreases in absolute value, and the limit as n approaches infinity of the nth term is most certainly 0, and so that converges. So the left endpoint has to converge. -2 works. Therefore, C is gone, and all we have to find out is what happens when x is equal to 0. At x equals 0, what do we get? Now we have 1 to the k, which is just 1 over k squared, and so that is a p-series. P greater than 1 converges, and so the right side must also converge, so D is out and E is in, and that does it. So again, if we needed to, I will, just for instructional purposes, I will go through how to find the interior of the interval of convergence, the way you would normally have to show this on a free response question. We're going to use the ratio test, and so we have the absolute value of the n plus first term, or in this case k plus first term, k plus 1 to the second, and then we're going to multiply this by the reciprocal of the kth term, and we would have x plus 1 to the k. Simplifying, it's not n equals, it's going to be k equals 1 to infinity. And here we will have k squared over k plus 1 squared. And we'll work with that in just a second. Then absolute value x plus 1 to the k plus 1 over x plus 1 to the k. Now k squared over k plus 1 squared, go back to this old limit problem, limit as k approaches infinity. I'll rewrite that first of all as k over k plus 1 quantity squared. Well, that's equal to, we take the limit of the inside function and apply the outside function at that limit, or evaluate the outside function at that limit. And we know that limit as k goes to infinity of k over k plus 1 is just 1. And 1 to the second power is still 1, and so this whole limit is 1, which makes that limit 1. Then x plus 1 to the k plus 1 over x plus 1 to the k is simply absolute value of x plus 1. That has to be less than 1, so our interior is going to be x plus 1 less than 1, greater than -1, or x greater than -2 less than 0, which we were able to deduce just by the fact that if you have an interval of convergence, then the interval of convergence is going to be symmetric about the center. And that'll do it for this problem.